All right, so I hope all of you are here already. So to those who are going to eat their lunch, so again, you can eat while listening or watching to our discussion. All right, so I hope all of you have already downloaded the Eagle CAD. Have you guys already downloaded and installed it on your computer?
Trial version lang sir kasi wala yung full version. Even iba yung layout dun sa video mo sir compared dun sa site.
Really? Sa akin, di naman ako gumamit ng premium. All right. So mine is also, I think this is an education. Tingnan natin. So may tatlong kanya. I think this, the one that I'm using is for education or student version. So sa akin, Windows. So I just chose Windows and then I click download. And then, okay, so let's just wait. Still loading. Because I didn't also avail the premium one. The one that I'm using is the free version. I just sign up, okay, and then that's it. Okay, so as you guys can see on the upper right, I have my name in here. So I just sign up and then, yeah, it is now working as it is.
Yes sir. Pero I notice yours says education on the top. Mine says free.
Really? Have you downloaded it on this website,
Yes sir.
www.autodesk.com?
Yes sir.
How about the others?
Free
What
din,
is the
sir.
version of EagleCAD that you guys have? Free then?
Yes, sir. Same then.
Is it also free? Because
Yes,
mine
sir.
is Eagle 9.6.2 education. Hmm. Well, this is not a cracked version. I also downloaded this one on their official website. So I don't know, but mine was downloaded and installed last year, I guess, or last year. So maybe there is a change, maybe.
Pero sir,
Not
I had
sure.
to apply for the education dun sa AutoCAD for to verify my account as a student, and it will take up to 48 hours pa daw.
Oh, I see.
Because I only made my account
I don't
today.
know. Maybe. Well, before last year, I guess, or last year, I just signed up and then it's working already. I didn't wait 5 minutes, 10 minutes. Anyway, so we'll see what we can do for today. Anyway, so this is just the start. So mostly are self-explanatory. So I have already uploaded, okay, the module 5. Okay, so please download this one now so that you can have your own copy. So Intro to PCB and EagleCAD PDF. So this one is not yet finished. Okay, so there's still a lot actually. So as you guys can see, this one is 87 slides total for now. Okay, but this one is not yet finished. So it's still on the process. So I'm still finalizing some of the images or screen captures right here, so that we can have a uniform and single or a one way, okay, in routing things, in adding components, in adding libraries, etc., etc. Because we have a lot of video, or we have a lot of tutorials on the YouTube. Yes, all of them have one goal, but they have their own ways, okay, or different ways on, you know, creating their own schematic. Okay, so that's why I have this step by step, so that we can have a uniform and one way of doing things. Okay. Anyway, so we'll go on with that one later. So supposedly, if you guys are going to take a look on our syllabus, we have here the introduction to circuit layout, okay, software tool, etc., etc., electronic packaging, wiring, and cabling diagrams. So before this week 5, actually, there is a, let's say, one meeting or two meetings before this week 5 that you should do a practice on how to use a driller, how to use a, what do you call that one? Anong tawag doon? Sa panghinang? Soldering iron. Yeah. So supposedly, okay, so I'll give you guys 1 week to practice on how to use this soldering iron, okay, because since our subject is laboratory, so you should have experienced it on actual. But since we are in on online distance learning, I won't be able to monitor or check if your ways of holding your soldering iron and then your lead is correct or no. But there's a lot of YouTube tutorials on how to use this one. Well, 3-minute video, 4-minute video will do just fine. The critical point is only the tip. Okay, so the tip is the one that is always getting burned. Okay, or it will what do you call this one? It will get destroyed, or it will melt easily if you don't know how to use it properly. Okay, so yeah, that is the most tips that they will give you. So as you guys can see right here, we have the copper wire. So you should always have this one. So this is very important. If you have a soldering iron, you should have a copper wire and of course a stand. Okay. So the role of this copper wire is you should always wipe it, okay, upon, or let's say while you're using your soldering iron and then lead, right? So you should always wipe it with your copper wire. Okay, do not let the lead stick on your soldering iron, especially in the tip, because it will melt or burn the tip of your soldering iron easily. Okay, so if you're not that careful, so it might only last 1 week. Then you have to buy another one again. Okay, so that's one thing that you guys have to experience. Okay, and one more thing. Okay, so of course, if you have a soldering iron, then you should also have lead wire. Okay, so this is the one that you're going to melt to combine two wires or to connect a certain connection, say from wire to PCB, or any connection that you wanted to connect on your circuitry. All right, so this is also one thing that you should also have if you want to practice using a soldering iron, and of course a wire. Okay, where is that wire? So you should also have a cable wire. So any cable wire will do. But we have a gauge wherein it has a specific width or radius, let's say 5 millimeter, 3 millimeter. So they have their own usage. So the standard is, I guess, 0.05 or 1 millimeter. Okay, thickness of the wire, okay, especially if it's going to use for practices like this one. matrix board. Okay, so if you want to experience it on hand, then I encourage you guys to buy a matrix board. Okay, this one. So you can have a 4x4, 3x3, or even a bigger one, 7x9. So it's up to you. And yeah, just ask the electronic shop what is the recommendable gauge size for the uh, wires, okay, especially if it's for PCBs. Okay, and for the soldering irons, I guess this one is not that expensive. So you can buy a soldering iron with a stud as a bundle, I guess, as for, I don't know, maybe 350 or 450. So if I were you, if you have the money, so yeah, just buy it. Okay, though I won't be able to check it since we are in online distance learning. So this is for your own sake. So this is for your own learning or experience. Okay, so I encourage you guys to buy this one. Okay, so wires is super cheap, maybe 5 pesos per meter. So yeah, maybe just less than 500 pesos, then you can have a soldering iron, lead, and then a PCB matrix part. All right. So yeah, that is one thing that you will miss. Okay. So the next one is practice in drilling a PCB. Okay. This is actually already the last part. Okay. Let's say you have already created or made your PCB or printed circuit board. Okay, the official one using the Eagle CAD. Then it is now your job to drill the holes on your circuit layout. Okay, so what are those holes? So those are where you are going to put your resistors, capacitors, VCC, ground, etc., etc. So in other words, you have to drill for every pins of your components. All right. So this is also one thing that you will miss. Okay, but then again, if you have the money, okay, if you really want to experience how to do it, then let me know. Okay, so we can talk, or you can chat me from time to time if you want me to check your work, if you are really doing it right or no. Or if you want to do it on your own, you can search on YouTube. So there's a lot of videos there which can help you to, on how to use a driller properly. Okay. Anyway, this is call this one self-learning. Okay. Once you have uh, experience in using this one, then you will know what is the rightest way to do it. Okay. Well, my only tip is, just do it straight. Okay, because there are others wherein they are drilling it 45 degrees down, okay, or not that 90 degrees, okay, 45 or negative 45. Yeah, so those are the things that you will miss. Another thing is this one. So supposedly you will also, create some projects. So any project will do. So I will let you guys propose any breadboard project, okay, and then just show me, okay, that it works on actual, because the one that you're doing on the fritzing is yeah, super simple, and I know that most of them are working because most of them came from the internet. But in here, I would like you guys to create a project using the, some simple components that you can find on the electronic shop. Okay, like the others created a mini sound system. So they bought a mini speaker. So the others created an alarm. So the others created on how to measure a water. What else? The others created, let's say, a burglar alarm, wherein if it's moved at least a little, so it has its sensitivity. then it will alarm, or the speaker will provide a sound. All right. So yeah, in total, I would say that this would take maybe at least 2 months. I mean, 2 weeks. Okay, including this one, the breadboard layout, soldering iron, experiencing on how to drill a PCB. And yeah, I guess those are the only things that you will miss aside from creating your schematic on EagleCAD. All right, so are we clear with that one so far? Hello, are you guys still there?
Yes, sir.
Okay, so as you guys can see, once we're done with the EagleCAD project, then yeah, that's it. So I highly encourage you guys to do the things that I have mentioned. Okay, since we have a lot of free times to experience a real PCB project. Okay, not just a virtual project. Okay, so this is the essence of a CpeDraft. All right. So do you guys have any other question before we proceed to our discussion?
None, sir.
None, sir.
None, sir.
All right. So I also doubt that we will be able to finish this module 5 today. So I'll just cut it in half, maybe 1 to 40. Yeah, first 40 slides, then we'll stop right there, and then we'll just continue the rest next meeting. Especially that this presentation is not yet finished. So even though we'll be able to finish this one, we won't be able to appreciate it since we are not on the printing part yet. So this is just choosing a PCB manufacturer. So we will actually skip this one because you are the one who's going to manufacture your own PCB. Okay. So of course you're going to print it, and then you're going to etch it on the PCB itself. Anyway, so let us start now with our discussion. So for the module 5, so this is an intro to PCB and EagleCAD. So what is PCB? So you guys have already know this one. So you've been talking PCB many times already. So PCB stands for printed circuit board. Okay, so it is mechanically supports and electrically connects electrical or electronic components using conductive tracks, pads, and other features etched from one or more sheet layers of copper laminated onto and or between sheet layers. Okay, so if you're going to take a look on those, so we have coppers. Okay, we can also have aluminum or nickel, so depending on the metal that you're going to use. But mostly, we're using coppers for conductive tracks. Okay, so it's cheaper, it's a lot more effective, and it's better, okay, than the other metals. All right, so components are generally soldered onto the PCB to both electrically connect and mechanically fasten them to it. Okay, so printed circuit boards are used in all but the simplest electronic products. So this is one simple PCB. Okay, so we have here the front and then the back portion. Okay, so mostly we are designing our PCBs on the top side. Okay, and then if we can really route it, okay, on the top, then that's the time that we can route it on the bottom. So as you guys can see right here, this one line right here and then another line right here is on the bottom part of the PCB itself, okay, or the circuit board. All right, so in total you have printed two, so PCB on the top and then PCB on the bottom. So those two are different designs. All right, so before the PCB, okay, so we have this kind of wire wrapping on our electronics. So everything is connected by wires. So as you guys can see, this one is a little bit messy. Okay, and like right now, it's much more beautiful. It's much more easier to understand and easier to troubleshoot. Okay, rather than with this one, that the conventional PCB. All right, so here's an example of modern PCB. Okay, so we have here the connection. So I don't know what are those, but those are components that is etched on the PCB. Okay, and then the uh, orange or the copper that you are seeing right here are the copper wires, okay, or the copper, call this one, conductive tracks or paths of our PCB. Okay, and then some are already soldered like this one. So this one is already soldered on the PCB, right? So here are some of the advantages of modern PCB. So of course, it's much more compact of size and saving of wires. So if you are familiar with our processors on our cell phones right now, smartphones, we have 7 nanometer, 5 nanometer, 10 nanometer, 12 nanometer. So as you guys can see, as time goes by, our let's say ICs, okay, ICs or PCBs are getting smaller and smaller and getting more powerful and powerful. Okay, so the smaller it is, of course, the more size that you can save, and then the more powerful that it can be, because like you can double the performance if you can uh, shrink it into half. Okay, and let's say having the same size, of course, will double the performance. And ease of repair and diagnostic. Well, this one depends. Okay, so ease of repair is okay if it's a normal project, like simple or small project. But if it's a very high-tech project or a high-end project, like maybe the circuitry on our phones, like it's very, very hard to see the paths. Okay, where is this one connected, etc., etc. So you need a software or a mechanical thing for you to be able to check it. Okay, but in most cases, this one is a lot easier than having this one. Okay, so yeah, that's why it's much more easier to repair and diagnose. And saving of time, of course, it will save you more time since instead of doing this one manually, okay, like putting the wires from here to here and there, just print it, okay, and then the wirings are already done. So all you need to do is etch your components, and then yeah, that's it. And then immune to movement. So compared to this one, so some of the components can be moved easily, especially the wires. But in PCBs, so since our wires is already printed on the board itself, so we could say that it's immune to movement, right? So it's already fixed on our board. And we have here tight connections and short circuits are avoided, okay? So in here, this is very, uh, let's say, prompt to getting short circuited, especially if, let's say, a rat, okay? Say there's a rat inside of this circuit board, and then he ate some of your wires, and that will cause a short circuit on some of your other components already. Unlike this one, okay, oops, here's our example. Like this one, so it won't be easily at the line. Like for example, if we have here a damage, so we can still make a remedy on that one. Okay, but the one good thing, even though it has a damage on this part, it won't cause a short circuit since the line was just cut. Okay, it's not swinging. Okay, and there's no chance that it will touch the other lines. Okay, so that is why it's short circuits avoided, or it's not prone to short circuits, right? And of course, low electronic noise. So instead of having a physical wire, having a PCB or a printed line is of course much more lesser the electronic noise. Okay, so we have here the explanation. So this leads to low radiation and pick up the electromagnetic waves, thus ensuring a lower crosstalk in between components and in between wire traces, which usually is a major concern in electronic circuits. Okay, and this one is also low cost since all you do is print it. Okay, and then you can already save a bunch of wires, right? And reliability. So all of the above mentioned are the factors that brings reliability in the performance of the circuit. Okay, so as you guys can see, we have a lot of advantages, though it also have a disadvantage. Okay, so having a printed circuit board path rather, so it will only able to carry less current. Okay, so if your project is made for let's say carrying high currents, maybe 100 amperes, 1000 ampere, then PCBs are not made for that project. So you need a physical wire or connection on that one. Okay, because mostly if we have this small printed uh, connection, this can only carry, I guess, a maximum of 1 ampere to 10 ampere. So more than that will, you know, put your PCBs at risk. Okay, why? Because it will create heat. Okay, so the higher the current, the more heat that it will release, and then the more the heat that it will release, then the more that it's prone in getting destroyed, okay, or getting burned. That's why we are sometimes having some burned PCB, okay, like maybe the Samsung Samsung Galaxy phones before. Some of their units exploded, so maybe it's carrying too much current on their PCBs. Okay, so that is one possibility. All right, and so PCB cannot be used for heavy currents. And soldering needs precautions. So this should really be done by experts or someone who's really good in soldering things, because this is a double-edged sword. Like soldering this one is okay, but uh, let's say you soldered it uh, improper, okay, or not proper, then it might cause the component to get burned and will not work. Okay, so you have to be careful in soldering some of your components, especially if it's IC. Okay, and yeah, so we have here types of printed circuit board. So we only have three actually. So we have the single-sided, double-sided, and then the multi-layer. But before that, I just would like to mention this one. So the creation of circuit pattern is accomplished using both additive and subtractive methods. So again, the conductive circuit is generally copper, and the other metals are aluminum, nickel, chrome, and other metals are sometimes used. Okay, so depends upon the spatial and density requirement, and the circuit complexity determines the type of board to be produced. So there are three basic variants of printed circuit boards as below mentioned. So for super beginners like us, okay, so this is where we are going to start. So single-sided PCB. So if possible, only do a top mounting of PCB. Okay, avoid doing a double-sided because it will only complicate things. But if it's really needed to put the components on the bottom, then that's time that you can use double-sided PCB. Okay, so you have components on the top and then you also have some components on the bottom. Okay, but if possible, if you can route everything on the top, then please do it. But if not, then you can do the double-sided PCB. All right, so they are self-explanatory. So single-sided is one surface only, and then double-sided are both sides. And for the multi-layers, of course, you have more than one PCB. Okay, So we have, let's say, 3 or more layers. So that's already a multi-layer PCB. So of course, we still have the top layer and then the bottom layer. And then the middle part is just, so you can have middle layer 1, mid layer 2, mid layer 3, and so on and so forth. So depending on how many layers you want to have. So this one is already super complex to create. Okay, so we will not be able to reach this part anymore. Okay, so we will only be able to reach this part, double-sided PCB. And then the rest are for professionals already, the one who's already, or the one who's really in the industry or the field of creating PCBs. All right. Okay, so before we proceed to the next one, do you guys have a question or clarification so far?
Answer.
Sir.
All right. Okay, so we're almost done with PCBs. So we have here the layers overview. Okay, so in an official created silk screen, I mean PCB. Okay, so we have this silk screen, but mostly if it's just a PCB, okay, like this, okay, so we won't be able to reach that part anymore. Okay, for that is for normal PCBs only. So it's only up to the solder mask and copper. Okay, but upon creating the Eagle CAD, so it's optional. You can actually add a silk screen. So this silk screen is just the labels. Okay, so let me give you guys an example. Like for example, this one. So this is an example of silk screen. So we were able to put here the word lily pad. Okay, so it is created by putting a silk screen. Okay, so the importance of putting a silk screen is for us to be able to know the labels of your components. Like for example, right here, I don't know if you guys can see this one. We have here the off and on. Okay, so without silk screen, we won't be able to put those text or words. Okay, but mostly without silk screen will do just fine. So that's optional. But if you want to have a much more professional looking PCB, then add a silk screen. Okay. So how to add a silk screen? So you can add a silk screen coating on the Eagle CAD software. So if we'll reach that part, then I'll be able to show you. But I doubt that I'll be able to reach that part because it's on the last part already. So like for example, this one. Okay, so adding silk screen outcomes. So as you guys can see, we have here the ground, AO, A1, A2, A3, A4, A5, BCC. So those words, yeah, those words are created because of silk screen. Okay, or you can do this one because of silk screen. Though, again, it is optional. So it's okay if you will not put those words or text or labels. So just by having this kind PCB is okay. Okay, so both of them works the same. It's just that this one has a label. All right. Okay, so going back, and then of course we have here the solder mask, the copper, and then the substrate FR4. So to those who still don't know what is the middle part of the PCB, that one is actually a fiberglass. Okay, it's just that it has a different materials. That's why it doesn't seem like a fiberglass, but that one is a fiberglass. Okay, it's made out of fiber. All right, so we'll stop here for now, and then we'll just continue the rest on the part 2 and part 3. Okay, so goodbye for now, and see you guys on part 2.